How many here are familiar with Agile software development? Great, and how many of you are actually using it in your jobs or in your organizations? Not many. So this Agile is very popular, and if you're not using it now, you'll probably be using it in 5 years for doing development. It's everywhere in the engineering world. And people sometimes use this as an excuse for saying we can't do security, or it's hard to do security because we're developing constantly producing code, as opposed to doing it the old way where we can have specifications and plan and everything. But really, Agile is not an excuse. The same security activities that you would do in a so-called normal or waterfall process, you can do in Agile. Some things need to be done up front as part of the planning, but even in Agile, there's a planning set where you're writing the user stories, which is the equivalent of software requirements in the Agile process. So you can do things like your threat model and your attack surface. And you may in Agile have to start with just a skeleton of those things, just the framework, and fill them in as you write the code, just like you do with user stories and just like you do with the rest of the plan in Agile. So security can be built into a regular process or an Agile process just the same. There's just a slightly different time and a slightly different way you do the same security activities. A threat model can be built in an Agile way, built up piece by piece as you're doing your development. The security user stories need to be included with the regular user stories, just like security requirements need to be done. And the security planning and scanning and all the things that you need to be done as part of the QA at the end of each sprint, as opposed to just at the end. But Agile, SDLC, waterfall, proper code, good code, secure code can be written no matter what your process.
And one problem that I've seen when I've tried to do this with security and Agile is that people who are doing, for example, Scrum are writing stories only for the functional requirements for their software. And what you have to do is put security stories in as well. So your security requirements need to be right next to all of the functional stories, and you need to be able to work those together. The other thing is that if you are building an underlying system, there are still a lot of requirements that you have to have from day one. You can't do little pieces and develop it as you go along. You have to have a foundation. And that's often where security is very important. So it can work with Agile, and in a lot of cases when you are iterating your development and new requirements are coming in and you're changing things, then you have to update your threat models anyway. So even if you're using a traditional waterfall methodology where you're doing everything up front and then you're developing and then you're testing and rolling out in one long thing, you're still probably doing little iterations in the middle of that process anyway. So you just have to remember to have an underlying security set of requirements, and you have to keep inserting security and updating it as you go along.
This Kirk is very agile.
Kirk is very agile. He's making things up as he goes along, but also Captain Picard has a grand plan in mind.
That's right. So Picard would use agile where appropriate and use other kinds of planning where appropriate as well. And Kirk would just hang ahead with the code.
Right.
So Wendy, let's talk about some of the scanning and penetration testing and security verification methods such as static and dynamic and hybrid and manual penetration testing. How do those things fit into the software security world, and what's the best method to use?
Well, if some of you don't know the different terms that are being used here, static analysis is usually used on the code files themselves. Products like HP Fortify or Veracode for static binary analysis. Dynamic analysis is used to test a running application as if you were an attacker. So it has to be up and functioning, and you're looking at it from the outside as if it were a black box. those two different types of analysis for application security have been around for a very long time. In the last couple of years, some companies are starting to try to put those together in a couple of ways. And they might call it white box testing, they might call it hybrid testing. But what they're doing in a lot of cases is they may have an onboard piece that sits on the web application server that is monitoring the stack directly. And it's watching the responses to dynamic testing that you can't always see from the outside. So for example, there may be activities or errors that are not being fed back externally. So this extra piece on the server will help to drive better testing and give more feedback to the dynamic scanner. Some other companies are trying to correlate the output from static analysis and dynamic analysis. And where we have seen this in our research is that mostly it's from dynamic to static. In other words, when you run a dynamic test and you get some findings, if you have a very good system put together, you can narrow down the problem to particular lines of code, which the static analysis can help you identify. I have not seen much coming back from static to dynamic, closing the loop yet, although I know that there are companies working on that. Probably the more different views that you get into your application as you're testing it, the better. And so I think we will see all of those different types of products coming together more often and being bundled more often. In fact, there are some companies that are not tracking those two products in different revenue streams anymore. So I think we're going to see a lot more collapsing of all of these different types of testing into one coherent product. But it will take a long time.
I've also heard the term glass box testing.
Yes, glass box testing also, where you're actually monitoring the execution of the application.
And also we should add the place in the process that manual testing and code review plays, because that's part of it as well. Automated testing can only go so far, and of course there's still problems with false positives even with the hybrid models, although that helps a great deal. So you actually want to get that independent set of eyes, that creative type of test that can be done through an automated scanning process, and a hands-on code review that can pick up security problems, logic problems, other things that a scanner might not be able to pick up. Of course, manual testing is expensive, so it's good to get a lot of the baseline stuff done with your scanner in one way or the other, get as much of that fixed as possible, and then do some code reviews along the way with the team with a bounded set of expenses. So you plan, I'm going to spend this much time specifically doing code reviews, and then at the end of the process, maybe choose to do some penetration testing as well, which is code review and penetration testing is kind of the manual equivalent of white box and black box.
Yeah, and you really do need to do manual testing in addition. I'll give you an example of a business logic vulnerability that a scanner would not pick up. If you know eBay, you know that a few years ago, you could see the usernames of other people who were bidding against you in an auction. And what they found out was that people who really wanted to win the auction would look up the usernames of the people who were competing with them. They would try to log in as them in eBay, and if they tried enough bad passwords, they would lock that user out. So they would wait until just the end of the auction, they would lock the other users out, and then they would win. So that, as a result, eBay had to stop displaying the usernames of all the bidders. That's the sort of thing that none of these automated tools could pick up, and that's why you still need manual penetration testing. However, a lot of companies that are doing dynamic testing and static testing are always working to automate different types of manual exploits so that they can keep automating these and feeding them into the tool so that they can save the human resources for even more complicated attacks. So there is a chain there where they're feeding different exploits as they
many other speakers around the conference come up with new attacks. So
They come up with new attacks all the time. So you will never be able to catch up with them. All right, Fred, how do you calculate the time to fix an application after you find out all the problems with it?
So this idea of time to fix is an excellent metric that a lot of people use. So the good news about having a question like this is, first of all, that you ask it. So you're actually thinking about what your process is and when you're going to fix it and how long it's going to take you to fix it and how important it is to fix certain things in a given amount of time. And in fact, if you know how long it's going to take you to fix something, that can help you plan. We talked about a WAF earlier. Certain bugs might be longer and you might want to use the WAF to fix those temporarily, other ones might be shorter and you might fix them right away. But the process of calculating this is difficult because you need to have a measurement point of where you start and where you end. And you can start from when the vulnerability was found. You can start from when the engineer was assigned the fix. You can start from when the engineer actually worked on the fix. And you can end from when the fix was checked in, when the fix was tested, when the fix was deployed. Depending on what you're trying to do, most likely you want to take the longest possible value. It may not look good in your statistics, but you really want to be counting from when the vulnerability was found to when the fix was deployed, because that's your period of exposure. It may not be the same as how you plan your work. So in engineering, they may use a smaller value to calculate the labor costs of doing a particular type of fix. In engineering, they may wish to know when the engineering started to when the code fix was checked in, so that they can measure across site, is this hard, SQL injection, is this hard when they're doing their investment planning. But for your risk planning, you need the longer value because that's your exposure.
And again, it depends on in what context you're fixing this. If you're under attack and you have to fix it very fast, then you're not going to be thinking too long term. You're going to be more like Captain Kirk who was getting out the fixer and putting it on the kill. Whereas you with the card, you're going to take a long view and look at all of your applications and try a systematic approach. Now, with some companies who have done a very systematic approach to fixing these applications, they actually get better participation from the vendors of those applications. They get a higher rate of response, rather than if they go to them one at a time, kind of ad hoc and say, can you fix this, can you fix this, can you fix this. Now, there are some companies out there who actually do code remediation as a service. There are not that many of them. One of them that's called Den Group, who I use myself for my projects, have done so many fixes that they now have a good model of figuring out how long it will take them to fix a given vulnerability, SQL injection, cross-site scripting, and so on. If you look at their website, they have a good presentation on how they figure that out. But it depends on your organization. It depends on how many dependencies that application has. It depends on how many resources you have to be able to put on fixing that application. It may take you a few months to free up resources. It depends on how soon you can get your quality assurance testers to test it. It depends on how long it will take you to do regression testing, unit testing, integration testing. If the dependencies on other applications mean the other applications have to be fixed as well. When all of that is done, I have seen in my own experience when trying to fix a very important application, the fix itself can take maybe 6 weeks, but the rollout, the deployment can take up to a year. It depends on how many resources you have and what you have planned for. Some of these fixes are at a level that is like a new software development project. And most CIOs do not budget for a new software development project when they have to fix these. So it can vary widely, and you have to know how your organization operates to be able to do this kind of guessing.
And like any metric, and this is a guideline for all metrics, once you start using it, you need to be consistent. So metric needs to be measurable. So that's why you have to think about where you start and end. Then you need to consistently measure it so that you can measure yourself to see what your improvements are. and it needs to be simple and clear. Like something like time to fix is simple and clear. And if you're using different metrics for different purposes, like the engineering cost planning versus the risk exposure, you need to make that clear. So time to fix shouldn't be used for both of those. It may be time to create a code fix versus time from vulnerability to deployment to fix, and use those as two different phrases so everybody's clear on what the metrics are and what you're measuring.
Yeah, I actually have a whole talk about this that I give at conferences as well.
It's an excellent talk. Go see it.
Did you see it?
I think it's how Greg read it.
Oh, okay. All right. I think you're asking me this one.
Yes. Actually, I'll go ask him. So, it's controversial sometimes, training, because people get their degrees and they get experience, and some people will say that training is not so useful, and other people will. So what's your opinion? Should developers actually be trained on security, or should they just know it?
That's really difficult, and in fact, we've seen security experts who do development themselves forget about the security part when they're actually writing the code. I saw a great interview with a very well-known security researcher who described how when he sat down to write this tool, he forgot about all the security, and after he was done and it was running, he had to go back and fix all the vulnerabilities he put in it. So you're thinking in two different modes when you're developing. And that's why I think you need a combination of general training, teaching developers what to do instead of what not to do. If there's another great developer I know, a security expert, who talks about if we taught people to secure development the way we taught people to drive, we would teach people to drive by saying, don't have that accident, don't have that accident, don't have that accident, but we wouldn't actually tell them how to drive safely. So the training that we have, that we need to do, needs to be along the lines of what to do positively. Because you can never list all the bad things to do. However, at the same time, when a developer is coding, and he or she is not thinking about security at the time, there are some tools, some plugins that can help to remind the developer as they're working to say, it looks like you were trying to take this input and you forgot to validate it. Would you like to validate it now? Kind of like that paperclip that used to be in Microsoft. It looks like you're writing a program. Would you like some help? So I think you need a combination of overall training and reminders, and at the same time, be aware of the fact that training may not always work.
So this is an issue very close to what I do because I'm responsible for the training products at Security Innovation, and this is our expertise in training developers. And there's been some good work done on the actual metrics of training and what it produces. Microsoft basically stopped development for a while, did a very serious SDLC and training effort, and then measured the differences. This was around the time when they were developing Windows 7, so the difference between previous releases of Windows 7, the difference between previous releases of Windows Server and Windows Server 2003. And you guys probably know, if you use those tools, there was a massive decline in vulnerabilities. It's not the magic bullet. You'll still have vulnerabilities, and you'll still have problems, and there'll still be new attacks. But when you do SDLC work, and especially when you train developers properly, you can really have a big difference in security. Part of the problem of what happens when training doesn't work is that it's the kind of training Wendy was talking about, which is before we learned more about how to do this developer training, it was the OWASP top 10, and it's important to know what the vulnerabilities are, but it was training from a security perspective. We are security people, we think like security people, and so we think, just like Wendy said, don't do this bug, don't do that bug. But developers don't work that way. I need to produce this code, here are my coding standards. They do things, they don't not do things. So they need to understand the things they need to do to avoid building those vulnerabilities in the first place. And there's not a one-to-one mapping. So it's not like, do this and you won't have cross-site. Do this and you won't have SQL. It's more like there's techniques like input validation and
error checking that work across multiple vulnerabilities. SQL injection in particular has some specifics, like parameterized queries, but in general, it's techniques that you build into your code. It's a way of thinking when you're building your code, and it's not don't do a cross-site, it's build your code this way as part of your process. In my company, it's not really security people who do application security, we're really engineers, or the other way around, we're engineers who do security, and that's the way you need to think, that's the way you need to train. We also talked about the spell checking and reference information. You need to have a companion to the training so that somebody goes and they does training, whether it's online or instructor, then they go back to the desk to code and they forget everything that they learned. So you need that reference information as well as a companion to the training. That's part of what we do, and that spell checking type of method with a plugin, that's part of what we do as well. So this is an important topic, and if you care more about how to train the engineers and what you need to do, I encourage you guys to stop by Security Innovations booth, and now I'll end my sales pitch.
Yes. The other thing, the question about certification. Michael Howard at Microsoft, who pretty much led their application security initiatives, says that software is not a safe building material.
That's very true.
And it's very true. We don't have the same advantages that, for example, civil engineers have or mechanical engineers. We don't have a standardized way of building things. We don't have a manufacturing model for software development. I like to say we have a literary model for software development, that every programmer wants to write their own work of art, and they want to do functions in whatever way they feel like doing it. And that's why there are so many different vulnerabilities that keep coming up over and over again. One solution that we could try is to standardize more of the building blocks of the code that we are creating. That will stifle their creativity, and they will hate that. But if we keep giving them secure modules to use and say always use these ones, like the Enterprise Security API, SAP, a set of libraries that do these security functions properly, and if you tell the developers just use that, then that's all right. But I know that a lot of the folks in the red shirts who are helping us today are in various engineering disciplines, and they will be able to get certified when they finish their education, and they will have codes that they have to build to. We don't have any of that yet for application security, but we should be working on it.
It goes back to the standards discussion we had before. But even that building block, in some cases, engineers who have difficulty with that, in some cases they're actually very happy because it frees them to be creative with the other part. So when an engineer is building something, security isn't their objective. Their business product or their game or their website or their mobile application, that's their objective. So if they have some tools that can help them just do the security, that's actually liberating. Frees them up to be creative, as opposed to having to think about all the security stuff that's not really their primary way of thinking like it is ours.
And now the question for everyone, are we actually getting any better at this? What do you think, Fred?
So yes and no is a good answer. I'd say that we've seen a lot of very bad breaches that happened at the application level over the last 2 to 3 years. We used to read about worms and malware, now every day it's SQL injection. Somebody downloaded everybody's credit card information by SQL injection. That's the big one, but there's still lots of others as well. So you think that, well, with all these problems, it's maybe getting worse. And I think what's actually happened is the attackers have gone for the new soft spot. So that's why we're having these problems. It's been bad for a long time, and they finally found it, and now they're exploiting it. But because they're exploiting it, we're also becoming more aware. So a company like ours that's in this business that do this stuff is finding we're getting more and more people coming to us, more and more questions. There's more and more discussions. Like 2-3 years ago at a conference like this, it would all be network and system level security. There wouldn't be as many application security talks. So we're beginning to become aware. We're beginning to talk about it. We're beginning to do things things about it. We're beginning to talk about what's good training, what's good process. So we haven't gotten to the end of getting better, but we've started getting better.
Okay, good. Thank you all for making it this far. Does anyone have any questions, or would someone like to tell us about their experience with trying to fix their applications? Yes.
What is your advice to